Hello and welcome back. Today we are talking about the standard normal distribution. If you did not check out my video on normal distribution, I highly recommend so. This is kind of a continuation of that. And let's dive in. So, the standard normal distribution is a special normal distribution with a mean of 0 and a standard deviation of 1. It is used as a common scale for comparing values from different normal distributions. So we use this scale when we want to generalize the information given. Um, and we'll get more into it. So, key characteristics. Here's what it looks like. You should recognize this from the previous video. And for our standard normal distribution, we always put the zero, we put 0 as the mean and 1 is our standard deviation. So plus 1, plus 1, plus 1. Likewise, minus 1, minus 1, minus 1. Okay. So again, key characteristics. It is bell-shaped and symmetric. The mean is 0. Our standard deviations are 1. The total area under the curve equals 1, and the horizontal axis is measured in z-scores rather than original units. So what does that mean? We're going to introduce z-scores here, but we're going to go way more in depth on that later. I think I have 3 or 4 videos on the subject prepared, but this is going to be a quick introduction to it. Okay. Relationship to the normal distribution. A normal distribution can have any mean and any positive standard deviation. The standard normal distribution is created by converting observations into z-scores. This allows every normal distribution to be analyzed using the same probability table. And that's what I mean by generalize. We could take any information, generalize it so that we can use the same probability table to extract whatever information we need from our data. All right, so we're going to introduce z-scores here. How do we convert to a z-score? Super simple equation. Z equals x minus mu over sigma, where z is our z-score, x is our observation, mu is our mean, and sigma is our standard deviation. Here's an example of how we could calculate this. SAT scores are approximately normal with a mean of 1050 and a standard deviation of 150. A student scores 1350. Okay. What's the z-score? Left that part out. So here's our given information. And just a note here, I'm going to repeat myself ad nauseum with this, but whenever I am given a word problem, every time, no matter what the subject is, the very first thing I do is I just write the given information in a little column on the left side. And I do this for so many reasons. Let's say you're being tested on something, and whatever you're tested on has like 5 to 10 equations that you learned over the course of that unit. Okay. By just listing your given information to the side with the appropriate variable association, it's really easy to confer what equation you need to solve that. And it turns it from a word problem to a basic plug and chug equation problem. So I do that all the time. It helped me out so much as a student. I cannot stress it enough. Students get overwhelmed and freaked out by word problems. This is the easiest way to make any word problem, just trivialize all your word problems. Okay. Anywho, so you're going to see me do this a lot. I'm probably going to repeat that. So here's our given information. All we do is just plug and solve. X is 1350, mu is 1050, and standard deviation is 150. And I'm just gonna bring this down here so we can just compare. Okay. So like I said, X right here, 1350 minus mu right here, 1050 divided by standard deviation, 150 gives us 300 divided by 2. Right. So 300 divided, I got a little ahead of myself there. Let's fix that. That should not be 2. The answer's 2. Gives us 300 divided by 150. That was a mistake. Which equals 2. Okay, so we get a z-score of 2. So what does that mean? A student's score is 2 standard deviations above the mean. If you get a z-score, so that trivializes all the data. Okay, so what does that tell us? Let's bring down this to compare it to this here. hopefully we have enough room. So the mean of our data is, oops, we can't see the white, can we? The mean is 150. Our standard deviation, or sorry, the mean is 1050. Our standard deviation is 150. So we keep adding 150 to this. I'm going to go under it in white here. So 1050 plus 150 is what? 1200. And then 1350. And then another 150 brings us to 1500. Okay. With a z-score of 2, see how that lines up perfectly with the 1350 here? We get the z-score 2 and we know, hey, that score is 2 standard deviations above the mean of 1050. So we can trivialize all information, all data sets with z-scores to very quickly compare, okay? And we're going to do another example in a bit about like what it looks like to compare two different types of data sets. One that's like, I think the question is SAT scores versus like your typical test exam, and the grading scale is different. So how do you tell which student did better based on the grading scale? I don't know if that's not in this video, but that'll be discussed in a upcoming video. Anywho, all right. And again, this is just an introduction to the subject. I'm getting a little ahead of myself, but to continue on, common mistakes, forgetting to subtract the mean before dividing. We got to subtract here. Using variance instead of standard deviation. Remember, so variance equals this. Where that's squared. And then, so that's our variance. Where standard deviation is this. Okay. Sometimes you have to derive all of this by hand. You're not always given the standard deviation or the variance. You're just given the data and you're told to figure it out. You got to remember, as when you get the variance, square root it. Now you have the standard deviation. Okay. These last parts. Okay. Another common mistake, misinterpreting the sign of the z-score. Sign is important. These could be positive or negative. We will go into that more later. And lastly, confusing a z-score with a percentile. That's kind of a good one. They are super similar. Percentiles will always be on a scale of 100%, where percentiles will be on a scale of 0 to 100%. Z-scores will be on a scale of, typically it's contained within -3 to +3. It can extend out without the outside of that range. You'll probably never see it outside of ±4. But point being, it's working within plus or minus 3 or 4, as opposed to the percentile being on a scale of 0 to 100%. Okay. All right. Why does this matter? The standard normal distribution allows us to find probabilities, percentiles, and unusual values using a single z-table or statistical technology. It is the foundation for hypothesis testing and confidence intervals, which I know all of the students I work with and all of my viewers are going to go into the field of science when they get older, and these are things we must be super familiar with. All right. Here's a little practice problem with our z-scores. Exam scores are approximately normal with a mean of 80 and a standard deviation of 5. Find the z-score for a student who scored 92. I'll give you a minute to pause here and take a stab. All right. Hopefully we paused and looked at this. Let's take a look. All right. Super easy. It's just plug and chug. Mean 80, standard deviation 5, student score is 92. Okay. Equation given here. The student score is our x value of 92 minus our mean of 80 divided by our standard deviation of 5. 92 minus 80 is 12. 12 divided by 5 is 2.4. Therefore, our z-score is 2.4. And we could say the student scored 2.4 standard deviations above the mean. All right. So I know this is supposed to be the normal, standard normal distribution. We got a little on z-scores here. Is the only way I can really give a practice problem. But it's important to understand the main takeaway of this should be how our standard normal deviation trivializes our x-axis here with 0, 1, 2, 3. And from that, we focus on z-scores for information. Okay. All right. Well, thank you for tuning in. As always, a link to the notes will be in the video description, and I will see y'all next time. Take care.